In today's digital age, data is everywhere. It's in our phones, our computers, and even our refrigerators. But what exactly is big data? Simply put, it's the massive amount of information we generate every day. Think about all the tweets, Facebook posts, and Google searches you do. That's just the tip of the iceberg. Big data is changing the game for businesses and our daily lives. Big data isn't just about size, it's about how quickly we can process and use this information. Imagine trying to drink from a fire hose. That's what dealing with big data can feel like. But with the right tools, we can turn this flood of information into valuable insights. Companies use big data to understand their customers better, make smarter decisions, and even predict the future. The term big data might sound new, but the concept has been around for a while. What's changed is our ability to collect and analyze this data. In the past, we were limited by storage space and processing power. Now, with advanced technology, we can handle massive amounts of data in real time. This has opened up a world of possibility. Big data is more than just a buzzword, it's a game changer in digital transformation. Companies that harness the power of big data are pulling ahead of their competitors. They're able to spot trends, solve problems, and create new products faster than ever before. From healthcare to finance, big data is revolutionizing industries across the board. The story of big data begins with a man named Claude Shannon. Back in 1948, Shannon published a paper that changed everything. He introduced the concept of the bit as a unit of information. This might not sound exciting, but it was revolutionary. Shannon's work laid the foundation for how we think about and process data today. Shannon's idea was simple but powerful. He showed that any piece of information could be broken down into a series of ones and zeros. This binary system became the language of computers. It allowed us to quantify information in a way we never could before. Think of it like the alphabet of the digital world. Just as we use letters to form words and sentences, computers use bits to store and process data. As computers became more powerful, we could handle more and more bits. We went from kilobytes to megabytes, then to gigabytes and terabytes. Now we're dealing with petabytes and even exabytes of data. To put this in perspective, 1 exabyte is equivalent to about 250 million DVDs. That's a lot of information. This exponential growth in data is what led to the term big data. But big data isn't just about quantity, it's also about the variety of data we can now collect and analyze. In the past, most data was structured. Think spreadsheets and databases. Now we're dealing with unstructured data, like social media posts, videos, and sensor readings. This variety of data types presents new challenges and opportunities. It's like having a giant puzzle with pieces that don't all fit together in the same way. Big data technologies help us make sense of this complex picture. When it comes to handling big data, cloud services are the unsung heroes. Companies like Amazon Web Services, AWS, have changed the game. They provide the infrastructure needed to store and process massive amounts of data. Imagine trying to build a warehouse big enough to hold all the world's information. That's what cloud services do, but in the digital realm. AWS and other cloud providers offer more than just storage. They provide powerful tools for data analysis and machine learning. These tools allow businesses to extract valuable insights from their data. It's like having a team of expert analysts working around the clock. The best part? You only pay for what you use. This makes big data accessible to businesses of all sizes, not just big corporations. One of the biggest advantages of cloud services is scalability. In the past, if a company needed more computing power, they had to buy and set up new servers. This was expensive and time-consuming. With cloud services, you can scale up or down instantly. It's like having a magic tap that can provide as much or as little water as you need, exactly when you need it. Cloud services also make it easier to collaborate and share data. Teams can work on the same data sets from anywhere in the world. This has been especially valuable during the recent shift to remote work. Cloud-based big data tools have allowed businesses to stay agile and responsive, even in challenging times. They've become an essential part of modern business infrastructure, powering everything from e-commerce to scientific research. Section 4, Scaling Up and Out, the Evolution of Data Architecture. As data grew bigger, our approach to handling it had to evolve. In the early days of computing, the solution to handling more data was simple: build bigger, faster machines. This is what we call scaling up. It's like trying to fit more people into a room by building a taller ceiling. While this worked for a while, it eventually hit limits. There's only so big you can make a single computer. The breakthrough came with the idea of scaling out instead of up. Rather than relying on one super powerful machine, we started using networks of smaller computers working together. This is the principle behind technologies like Hadoop and distributed computing. It's like solving a big problem by dividing it among many people, each working on a small part. This approach allows us to handle massive amounts of data more efficiently and cost-effectively. Scaling out has other advantages too. It's more flexible and fault-tolerant. If one computer in the network fails, the others can pick up the slack. This is crucial for businesses that need to process data 24/7. It also allows for easier expansion. Need more processing power? Just add more machines to the network. This scalability is what makes big data processing possible on a global scale. The shift from scaling up to scaling out has changed how we think about data architecture. It's not just about raw processing power anymore, it's about designing systems that can work together efficiently. This has led to new job roles like data engineers and cloud architects. These professionals design and maintain the complex systems that make big data processing possible. They're the architects of the digital age, building the infrastructure that powers our data-driven world. The 3 V's of big data: volume, velocity, and variety. These are the key dimensions that set big data apart from traditional data processing. Let's start with volume. We're dealing with enormous amounts of information. We've gone from gigabytes to terabytes, petabytes, and beyond. The second V is velocity, the speed at which data is generated and processed. Now we need to handle data in real time, like social media feeds or stock market transactions. Variety is the third V. We're dealing with a wide variety of data types. This includes unstructured data like social media posts, videos, and sensor readings. Big data technologies help us make sense of this diverse information. Advanced analytics and machine learning turn raw data into valuable knowledge. Section 6, Big Data in Action, Real-World Applications and Impact. Big data isn't just a theoretical concept. It's making a real difference in the world today. Let's look at some practical applications. In healthcare, big data is revolutionizing patient care. Hospitals use data from electronic health records and wearable devices for personalized treatments. Retail is transformed by big data. Companies like Amazon use data to understand customer behavior and preferences. They can predict what you might want to buy before you even know you want it. In finance, big data is changing how we detect fraud and manage risk. Banks use machine learning to spot unusual patterns indicating fraud. Big data extends to urban planning and environmental management. Cities use data from sensors to traffic flow and reduce energy consumption.